Hi, so in this video, what I'm going to do is show you how to express an equation of a plane in its parametric form. So, from the vector equation of a plane, we can then express it in its parametric form. For a plane with the vector equation r equals a plus tb plus uc, the parametric form is defined as r equals essentially the vector x, y, z equals in an array a1 plus b1t plus c1u, and then repeated for a2 plus b2t plus c2u, a3 plus b3t plus c3u. So essentially the components of the point and then the two non-parallel vectors. So a1, b1, c1 are all the x components of those parts, and then a2, b2, c2 would be the y components, and then the z components. Another way of expressing this would be the system of equations there, xr equals a1 plus b1 plus c1, and then the system of equations there. And finally, another way of expressing it would be r equals the system of equations, but with their components I, j, and k. They all mean the same thing. What I'm going to do is show you how to convert the vector equation of a plane into its parametric form. I think maybe in the video those equations are a bit small to see, but r is 2, 1, negative 4. r equals 2, 1, negative 4 plus t, 1, negative 3, 9 plus u, negative 6, 0, 6, and I'm going to express that in parametric form. So that all I've done is I've read off each of the components, so 2, 1, negative 6, 1, negative 3, 0, negative 4, 9, and 6, and I've expressed that in the third form, as that's just the one I prefer. Ultimately, if you do it for any of them, then it's correct. Okay? So the next thing I want to do is we've got example 2, find the Cartesian equation of a plane. So really what we're just going to do is, now that we know the three different types, the Cartesian, the vector, and the parametric equation of a plane, I'm now asking you to get back to the Cartesian equation of a plane, having been given the parametric equation of the plane. Okay? So, there's also a mistake in that question. So what I'm going to do, if I go through my methods of how I'm going to get there, I've got the parametric equation of the plane. From that, I can get the vector equation of the plane. And from the vector equation of the plane, I can get two non-parallel vectors, which I can then take the cross product of, which will give me the normal to the vector, the normal to the plane, and then I've also read off from the vector equation of the plane a point on the plane. So I'll have everything. Okay, so I'll go through that. So far, what I've done is I've written this parametric form in its vector form, and then I've read off that point on the plane must be 2, 1, 3, and then two non-parallel vectors are going to be 1, 1, negative 1, and 3, negative 3, 7. So my next step is to find a normal. So now that I've got a normal to the two non-parallel vectors, I can then, using my, if I remember, the Cartesian form of a plane, which is ax plus by plus cz equals d, where a, b and c as just any point is a normal, and then I can calculate d by by substituting in any point. So there, what I then just did was, using the point that I read off the plane, 2, 1, 3, I've substituted that into the Cartesian form to calculate d, and then so I ended up with d equals negative 34, so then the equation of the plane is negative 10x plus 4y minus 6z equals negative 34. And that is the parametric equation of a plane being converted into the Cartesian equation of a plane.